folks, and welcome to this lesson on balancing chemical equations. Now, due to the laws of how matter works in our current universe, if you have a chemical reaction, whatever you start with needs to be whatever you end up with. So when a chemical reaction happens, you shouldn't be losing anything or gaining anything as a result of it. However, in some cases, when you write how a chemical reaction is written, so if you write the skeleton equation for a reaction, you're going to find that it's not balanced. So if you take a look at this reaction here, you can see that there's one sodium on the left, one sodium on the right, and one copper on the left and right as well, but you have two coppers on the left, whereas you only have one copper on the right. Chlorine. Where did those chlorines go? So this particular reaction, as it is written, violates the law of conservation of mass. And so that means that this, as it is written, would not happen. So what do you do at that point? Well, you have to figure out a way to make them equal. And it turns out the way nature makes these things equals is it uses different ratios. So in terms of the physics and chemistry of things, these reactions do resolve themselves. You just have to figure out how the numbers work out. So if we take a look at what's on the left and what's on the right, and when I say left and right, I mean if you take the arrow of a reaction as sort of that cutting line, the reactants are on the left of that arrow and the products are on the right of the arrow. So left of the equation, right of the equation. So when we take a look at our sodiums, you can see that there is one sodium on each side. For our coppers, you can also see that there is one on each side. And the chlorines was where there was an issue. So you had two chlorines on the left, but one chlorine on the right. So this is what we need to deal with to make sure that it does balance. So we could add another chlorine on the right, but the issue is this. On the right, chlorine doesn't come by itself. It comes as a group with the sodium itself. It is sodium chloride, not just chlorine. So if you are adding a chlorine, you are going to have to add a sodium as well. So if this is the case, yes, we do now have two chlorines on the right, but we also have two sodiums. So now our coppers and our chlorines are balanced. In terms of our sodiums, you can see that there isn't. You need more sodiums on the left. So if we have another sodium on the left, in this case you can see that sodium is an element here. It does travel on its own. So you can just add sodium on its own. So now we have two sodiums. So we can see that our reactants and products are balanced, but how do you show that in your reaction? Well, the way that you show this happening is through coefficients. Now, coefficients are the numbers that go in front of a chemical compound or the formula of a chemical to show that there are that many of this whole thing. So we have two sodiums. And in the case of our sodium chlorides, we have two sodium chlorides. We are not going to be adding on subscripts because this means that the compound itself is Na2 if we were adding sodium here, which means that it is a group of two sodium atoms, which isn't the case. What is happening here is that we have two sets of single sodium atoms. So this is not correct. You do not use subscripts to indicate what is happening. You use your coefficients. Another thing is if you're adding in subscripts, that can change the entire chemical itself. So that's another reason for why you're not going to be doing that. Alright, so I'm going to suggest that you pause the video here and try to balance this particular reaction. Alright, from here you should be able to see that you have one sodium and you have one oxygen. Now oxygen is a group of two oxygens. So you can see that it's O2, so you have two of them, they are a group. In this particular case, you have sodium oxide, and one sodium oxide is made up of 2 sodiums and 1 oxygen. So if we take a look at our reactants, we have 1 sodium. In our products, we have 2 sodiums. In our reactants, we have 2 oxygens, and we have 1 oxygen. So you can see that it's not balanced. Choose either one of them to start with. Usually in balanced chemical equations, you leave the oxygens and the hydrogens to the very end because typically you end up seeing oxygens and hydrogens in several different places. So if we use that rule, let's balance out our sodiums first. So by adding another sodium on this side, now you have 2, and those are balanced. Now in terms of our oxygen, you need more oxygens on the right, so that means we have to add another one of this whole thing. In which case, yes, our oxygens are now balanced, but we also have 4 sodiums on the right. So if that's the case, we need to go back and add some more sodiums. And now everything is balanced. Make sure you use your coefficients to indicate how many of each of these you have. And that's it. Here's one more. Try it out again by pausing the video. So in this case, we have selenium trichloride and oxygen reacting to form selenium dioxide and chlorine gas. I'm going to go a little bit faster. You can see that our seleniums are balanced, our oxygens and chlorines are not. I'm going to choose to do oxygen later, so to balance the chlorines, you need to do this. So you'll see that you have 6 chlorines on both sides, but you're also going to see that now your seleniums are not balanced. You have 2 on the left and 1 on the right. So you're going to balance that afterwards. Your seleniums and chlorines are now balanced, so left is the oxygen. So from here, if you count everything, you should see that all of your elements are balanced. Now you need to use coefficients to write it all out. And there you go. Now, one thing to keep in mind when you're doing your balancing is that there is going to be a smallest number ratio for your different coefficients. As you're doing your balancing, you might make a mistake and you might end up using, say, 4 of the selenium trichlorides, 4 of the oxygens, 4 of the selenium dioxides, and 6 of the chlorines. If that happens, it's fine, but you need to make sure that you reduce it down to its lowest number ratio for those coefficients at the end of it. Otherwise, your balancing is not correct. That's the end of this lesson. I'll see you next time.